I'm going to continue our lesson. Today we are going to cover pages 106 to 108 uh, about electrolysis of molten compounds. If you look at this picture, for example, we have one molten compound, like for example, something like here we have lead to bromide. Okay, when we have a lead to bromide dissolving in the water, so two compounds, two part of this compound can be separated. One is a lead to ion and another one is a bromide ion. So bromide ions have a negative charge. Okay, so they are negative particle. They are an ion. They can move towards anodes. Anodes are interested to receive electron. So bromides have electrons. They have extra electrons. They are an ion. So they can donate electron to anodes. So bromide change to the atom form. They change from an ion form to atomic form. Okay. Here there is a comment here. Bromide ion donates an electron to the anode, and then they have convert to a bromide atom. So each two bromide atom can attract to each other, and then they can make a molecule form. Okay, molecule form of bromine. So bromine is a gas. So when two bromine atom combine together, and then they form a bromine molecule. So bromine molecule is form of gas, and then they can be released from the place. Okay, they can be released. So this electron in anode can can travel through the wire here. Okay, move towards a positive side of a battery. Okay, there is a battery located here. So this battery can attract the electrons on the wire through the wire, and then pass to the another side. So another side here, the electron can be attract to the positive side. So another side of the battery, which can this side, the negative side of the battery, can distribute the electrons more on the cathode side. Okay, there is a cathode. So cathode is contained of electron. Electron can be distributed here, and if you remember at the first step, I said that we have a molten compounds here. The positive part of the molten compound, which is cation. Okay, the positive charge cation form. Cation can attract to the cathode side. Okay, the cathode in electrolysis, because they have a positive charge and there are lots of electron on the cathodes, so they can receive electron. So lead to Pb2 plus, the cation, they have two positive charge, so they can receive two electrons from cathodes. So they will be changed to the atomic form. When lead um, when lead has converted to atomic form, so this is heavy metal. Okay, uh, lead is a kind of metal. When they form as atom, so they will be deposited here, okay, at the bottom of the either bottom of the container, or they can be deposited around the cathodes. Okay, mostly they deposited around cathodes here because they are metal, so they will not form of the gas and leave the place. In opposite, bromine, they can form a gas, and then uh, they can be released from here. But metal like lead and one other part of the compound, molten compound, can be deposited here. So um, keep in your mind that molten ionic compound is electrolyzed. uh, there are two important events. One, metal is always formed at cathode, and then they deposit there. And non-metal, in the previous example, metal is lead and non-metal is bromine. So the non-metal is always formed at anodes. Okay, they attract on anodes. So it depends on the type of non-metal. They may form of the gas and leave the place, but it depends on non-metal. So for the section industrial electrolysis of molten compounds, you can have a self-study and memorization. So this table also is important. Try to take a note and memorize this table. So that's all for today. Please study hard and memorize every day. Thank you so much. Take care.